Hey, what's up guys, and welcome to a video all about the atom and the periodic table.
Caught in a landslide, no escape from reality. Open your eyes, look up to the skies and see. I'm just a poor boy.
Let's talk about the atom. The atom is defined as the smallest representative particle in an element. Now, an element is a pure substance made entirely of a single atom.
Atoms are made up of subatomic particles called protons, neutrons, and electrons, and these subatomic particles have their own special characteristics. Protons and neutrons occupy the center of the atom, the nucleus, and the electrons orbit around the outside. This is because of the conflicting charges between the protons and the electrons. Protons have a positive charge, but electrons have a negative charge. Neutrons are neutral and have no charge.
Combine these three particles and voila, you have a fully functioning atom. But what distinguishes some atoms from other atoms? Well, elements have a certain number of protons and neutrons and electrons. So what makes them so different from each other? It's the number of protons. Every element that we have discovered has a different number of protons. This number of protons is referred to the atomic number. These defining characteristics help us determine properties of elements such as atomic mass and even electric charge. We can find the atomic mass by adding the number of protons with the number of
Neutrons.
Carbon, for instance, has 6 protons and 6 neutrons, so its MAU is approximately 12. And with all these elements, we need some way to organize them because there's no possible way anyone can memorize all their properties, all their charges, what they're made of, so it'd be pretty difficult. So what did we do? We made a table.
Throughout history, we've invented many tables. The dinner table, the pool table, the multiplication table, the air hockey table, the list goes on. But the most important table that we've ever invented is the periodic table of elements. Though it's not a physical table, the periodic table of elements is an organized arrangement of all 118 elements that we've discovered thus far. But let's get deeper for a second. Who invented the periodic table and when, and why is it so useful to chemists today? Allow me to take you back around 200 years or so to a man named Dmitri Mendeleev. He was born in Russia and studied in St. Petersburg at the same university as his father, Ivan. He would discover that many elements that had already been discovered had very similar properties, such as sodium and lithium's high reactivity to water. With this information, Mendeleev would take 60 elements, which would later become the first periodic table, and organize them into increasing mass. This meaning that elements that had similar properties would be in close proximity of each other. And in 1869, Mendeleev would go on to publish these findings in something that he liked to call the dependence between properties and the atomic weights of elements, or as we better like to call it, the periodic table of elements.
The periodic table is big, with 118 known elements on it, but we can still manage to fit it on an 8x11 piece of paper. And now that we know the atom and the who, what, the when, and the where, we can finally get into the why. The periodic table is a condensed table of information on every single element. And the key to using this information is reading the table, so get out your periodic table and follow along. The periodic table is composed of vertical columns, called groups, and horizontal rows, called periods. But what really makes the table so special and unique and useful to scientists of all fields? Well, the answer is actually quite simple. So the table orders the elements by increasing atomic number. So over here, we have the alkali metals. Next are the alkali earth metals, followed by the transitional metals. And over here are the post-transitional metals, outlined by the metalloids. Here we have the nonmetals. And in group 17, we have the halogens, and group 18, the noble gases. And down here we have the lanthanoids and the actinoids. So here, looking at an individual element, we have carbon with 6 protons, with an atomic number of 6, and the atomic symbol C for carbon, of course. And down here, we have the atomic mass, which, as previously stated, is the number of protons plus the number of neutrons. So, when we're looking over the table, we can obviously see that some elements, like hydrogen, have an H for hydrogen, but other elements, like silver, have an Ag for their atomic symbol. So if you didn't know already, every element has an actual scientific name. So, the scientific name of silver is argentum. So, the atomic symbol for silver, which is Ag, comes from argentum. So we just cross out a few letters here and there, and boom, we have our silver. So, fun fact, when the Spaniards first arrived in South America, in the country Argentina, and they saw what we now know as today the Andes Mountains, they decided to name the country Argentina based off of the big silver mountains that they saw there. And another fun fact, did you know that the only letter not on the periodic table is J? Yeah, it's not there. Pushing that to the side, let's talk about electron orbitals. So thinking of electron orbitals is like thinking of our solar system. So in the center we have the nucleus of the atom, which acts like a sun to the atom. And then floating around it are the planets, electrons. So on each different orbital we have differing amounts of electrons. So when we're thinking of electron orbitals, the orbitals are actually relative to the groups and periods on the table. So over here we have our s orbitals for our first s orbital, and as well as these two columns. And over here we have our p orbitals. And in the middle are d orbitals. So the s orbitals only hold 2 electrons. So when we're looking at this side of the periodic table, we can find what number orbital it is by looking at the period number. So here we have 1s, over here we have 2s, over here we have 3s, and so on and so forth down the row. Here we have our p orbitals, which hold 6 electrons against the s orbitals 2. And we do the same thing with the p orbitals. We just go across and we look at the period number, which is 2. So we have 2p, followed by 3p, and then 4p, 5p, and so on down the periodic table. So with the d orbitals, it's relatively the same thing, except there's a special rule. So whatever period number it is, we subtract 1, so over here we have 3d, whereas this would actually be a 4s, and this would be a 4d, and this would be a 5d, and so on and so forth down the table. Periodic table is a condensed table of oh my god.
Atoms are made up of Atoms are made up of subatomic. And I forgot it. I could say the word now, but I forgot what I was going to say after that.
Are you ready? Well, are you?
I said go! God damn it.
This is because the conflicting
Out, okay? Just cut that part out. Words! I love words! Words are great! Elements. The last word is elements. I can speak. It's good words. I love words. Words are great. English. Atomic masses of elements. Oh my god.
because I forgot my line. I can touch it. Whoa.
Science rules.